Okay, so on this one, we got the graph of a function, and they want us to find g of 3, but they're not giving us the name of the function, or they're not giving us the actual function and function notation. But what g of 3 means, and this is something you really need to get, really make sure you understand it really well. G of 3 means when x is 3, what's y? That's what it means. G of 2 means when x is 2, what's y? F of 9 means when x is 9, what's y? But instead of writing out this sentence every time, we just say G of 3. Okay? It's not G times 3. This notation has nothing to do with multiplication. So when x is 3, what's y? Well, when x is 3, y is 5. Oh, okay, cool. And that's it. The problem is done. There's nothing else to do. Let's try another one. All right. So what's f of negative 2? Well, so when x is negative 2, what's y? Well, it's 1. A height of 1 corresponds to that. All right. Let's see if I can find another one that's a little different. Okay, this one's just a little tricky to read, but it says when x is negative 2, what's y? Looks like about negative 1, a height of negative 1. It's kind of tricky to tell. I mean, I could certainly see an argument for it being the height of that point being maybe like -0.5 or -3/4 or something. But I think what they're going for is -1 on that one. In fact, let's just find out. Yeah, -1. Okay. Anyway, but that's how it's done. So that's a good thing to practice. It's not tough, but it is definitely a good thing to practice. Okay, this time we're doing something similar. They're asking us to find g of x equals -1 and g of 0. Now, g of 0, that's like what we were just doing. Okay, when x is 0, right there, what's y? Well, y is height 3. Okay. So what does g of x equals -1 mean? That's essentially, remember, g of x, that's like your y. So this basically means y equals -1. So they're saying when y is -1, what's x? Well, y is -1 is right there. And that occurs when x is -2. But it also occurs when x is +1. So -2 and 1 are the two solutions for that first part. So, so right here, they're saying, here's the y value, go find the x, y value of -1. Over here, they're saying, here's the x value of 0, go find the y. You need to get familiar with this notation, be able to read it. That will make life easier in algebra. All right, now they say just go find the domain and range again. But they do have these dots at the end, not arrows. So that means that the function just stops there, but we're not including those endpoints. Everything up to those points, but not those points themselves. Okay. And they also reiterate that by saying, hey, okay, the entire graph is shown. There's nothing that's off screen like you normally have. So the domain, what have we got here? Well, the domain is all the x values that are being used. So you could think of it this way. If I crushed or squeezed that function into the x-axis, what part of the x-axis would it cover? Well, it would cover everything from there to there, which would be everything from -5 to 3. Okay, so -5 to 3, and they wanted an interval notation. So I'm going to put parentheses around it because of those open circles, suggesting that we don't include those actual endpoints, just everything up to them. If those circles were closed in, then I would have put those brackets instead. Okay. Now I need to do some erasing. Okay, now what about the range? Okay. So the range, that's the set of all y values that are being used. So if I press this thing into the y-axis, what part of the y-axis would it cover? Well, everything from 4 down to -3. Okay, so our range is going to be -3 to 4. You always put the smaller number on the left, just like on the number line. And again, I'm using these parentheses for the same reason, because of those open circles. Okay. And that is how you find the domain and range from a graph. Incidentally, they didn't ask us to do it, but this would be the domain and the range. In inequality notation, I would write it like this, if they ask you to do it. But they asked for the interval notation. All right, let's do one more of those, and I need to zoom out just a little. Okay, so what would be our domain? Well, if we press this thing into the x-axis, it's going to be everything from there to there. Now I've got this filled in circle, so when it heads down to the x-axis, it's still filled in. Okay, so the domain is going to be everything from -3 with a bracket because of that filled in circle to +2 with a parenthesis because of the open circle. Okay, so what about the range? Press everything into the y-axis. And all y values from -5 to +4 are being used. So the range is going to be everything from -5 bracket to 4. Okay. And that's how we do it. Okay, so once again, it says, here's a function. Go plug a number in for x. Big deal. Now it's a fraction, but who cares? That doesn't really make anything, that doesn't change anything. So g of -8 would be, again, that means when x is -8, what's y? So I plug -8 in for x. And let's see what we get here. I don't know. So we get 2 times -8 is -16. -16 plus 16 is 0. And you're not allowed to divide by 0. Okay. Oh, you don't believe me? Well, let's check it out. You will soon be a believer. So if I divide 12 divided by 0, error, doesn't work. See, he thought I was kidding. So for that one, we would say undefined, no solution. That's the only time you're going to get no solution on these. Okay. Now, what if we said, let's go find g of 3? Then we'd say, all right, 12, 2 times 3 plus 16, 12 over 6 plus 16, 12 over 22. Yeah, we can tidy that up a little. We can cancel a 2 out of the top and bottom and get 6/11ths. So on the graph of this function, when x is 3, y is 6/11ths. This is a point on the graph. This is not interval notation. I know that by the context of the problem. All right, so they say, here's a function, find all values that are not in the domain of g, not in the domain of the function. So numbers you're not allowed to plug in. Hey, remember a moment ago when we said, hey, you can't divide by 0. So all you got to do on these is just say, all right, well, when is the denominator equal to 0? So you just set the denominator to 0 because that's what's going to give you evil values. So if I add 4 to both sides, I get x squared is 4. And then I take the square root and I get plus or minus 2. So 2 or negative 2. You can write it either way. So there are two solutions. There are two excluded values, two numbers that if you plug them in for x into this function, then you're going to get an error message like I did on my calculator a moment ago. 2 and negative 2 are the two guys that are out of bounds. They're like the people you'd invite to a party and they break stuff and they get drunk and cause problems. Okay. So when you're looking for excluded values, you typically just set the denominator equal to 0, solve, and then that gives you what's out of bounds. And it gives you a face with glasses. Isn't that nice? Okay, so on this one, it says find the domain of the function. All right, so there's no denominator, so we don't need to worry about, dividing by 0. But there's two main situations where you can have problems and that will cause you to not have, or cause you to have numbers that are not in the domain, like that last problem with 2 and negative 2. The other situation is with square roots, because you can't do square root of a negative. That's not strictly true, but we're going to continue to labor under that delusion that you cannot do square root of a negative. So 8 plus x, whatever's inside the square root, must be at least 0. It can't be negative. We know that. Well, that's all I've written down there. Whatever's inside the radical, whatever's inside the square root, can't be negative. It must be at least 0. And then you just solve, and you got it. So you're always going to set whatever's inside the radical greater than or equal to 0 every time for these. Okay. So in interval notation, our answer is going to be everything from negative 8 with a bracket because of that or equal sign up to infinity. Just keeps going and going. And infinities always get the parentheses. So what if we wanted to explore that just a little bit to understand a little better? Okay, let's put that in the calculator. And so we'll plug in the function. Let's see what was 8 plus x. Okay. 8 plus x. Okay. First of all, let's go to the table. So I'll go second graph. And we said that everything is fair game except things that are smaller than negative 8. Well, look at this. When I plug in 2 into the function, I get an answer. So yeah, 2 is in the domain. When I plug in 5 into the function, I get an answer. 5 is in the domain. Okay. H of 5 is 3.6056. H of 8 is 4. But what if we go this way? Uh-oh, look at that. Yeah, we said that anything that from negative 8 on up is in the domain. It works. You plug it in, you actually get an answer. But if you go smaller than negative 8 for numbers you plug in for x, then it doesn't work because you're doing square root of a negative. So negative 9 is not in the domain. Negative 10 is not in the domain. Anytime you get an error message, you're working with a number that is not in the domain of the function. What about the graph? What does that look like? Check that out. So for the graph, again, talking about the domain, we say, well, let's just press the graph into the x-axis. And what does it cover? It covers everything from here over, doesn't it? Everything from negative 8 on up. That's exactly what we already determined from the table and from actually simplifying it by hand. So those are some alternative ways of thinking about it that will help you to understand domain and range a little more.